Okay, so sections 4.1 and 4.2 are on logarithms, and I'm very sad that we don't have a class meeting for this, like a formal in-person class meeting, because I've found uh, even like my calculus students in the past have had issues with logarithms, um, but we're gonna get through this, and it'll probably be okay. I'm also a little bit sad because normally what I would do in class is show you a video uh, of the log song from Ren and Stimpy. You should Google that or like search it on YouTube or something. I was told by my first 111 class that it was deeply disturbing, but I grew up watching Ren and Stimpy, so that was sad. Okay, on to math. We're going to start off with a definition. If a is a positive number, then the logarithm base a of x is defined by log base a of x is equal to y if and only if a to the y is equal to x. Okay, so that's probably a whole bunch of nonsense right now, since we've never talked about logarithms before, and you might not remember them from whatever math class you last took. So I want to look at an example first. And the example I want to look at is the common logarithm. Which is just log base 10. So this is base 10. So sometimes you might see just log of x with no base. If you see this, imagine a 10 being there. So anytime you see log of x, we are almost certainly talking about log base 10 of x. And we do need to be a little bit careful because since we're doing online classes now, I assume some of you may have worked your way over to Wolfram Alpha. When Wolfram Alpha writes log of x, they actually mean something different. So I would suggest that you maybe hold off on using that to help you with any problems you're having with logarithms. So what is log base 10 of x? Probably most importantly, it's an exponent. Okay, so in particular, it's the exponent that we must raise 10 to in order to get x. So what I mean by that is if log base 10 of x is equal to some number y, this means that 10 to the y is equal to x. So in reality, the logarithm is just an exponent. Maybe another way to write this is 10 to the log base 10 of x is equal to x. And you can imagine there aren't always values of x that I can plug into here, or I can't plug in all possible values of x into here. So some numbers I can't plug in. In particular, what if x is equal to 0? Then, when I write log base 10 of 0, I'm looking for an exponent. So that 10 to this exponent is equal to 0. Does such an exponent exist? The answer is no. So you might be tempted to say, oh, what about 10 to the 0? Remember, 10 to the 0 is 1. So I'd be a little bit careful right now with what numbers you plug in to the logarithm. Also, this definition up here that I'm putting a star by and also boxing it in, that says log base a of x is equal to y, if and only if a to the y is equal to x, is super, super important and super helpful for all things logarithmic, however, I don't know how to speak, but this is really important, and all of the issues that you will run into with logarithms in this class, I promise, can be solved using this definition. So make sure you know this. Like, do all of these problems and get real familiar with it. So let's start off with problem 1, which says convert each exponential equation into a logarithmic equation. So I'm going to rewrite it down here. Log base a of x is equal to y if and only if a to the y is equal to x. And what I'm going to do is I'm going to go through each one of these, maybe not all of them. I think you guys can handle some of them on your own, especially because, as usual, the solutions are posted on Blackboard. But I'm going to go through each one of these and figure out what a, x, and y are equal to. Okay, so if I have something to an exponent is equal to something else, that means I'm going to use, let me label this 2 and this side over here with the logarithm 1. So what I'm asking you to do for problem 1 is to go from 2 to 1. So looking at equation, like part 2 of the equation, a to the y is equal to x. For part A, I have 4 to the 3 is equal to 64. So the base, which is a, is going to be 4. The exponent is going to be 3. And x is going to be equal to 64. And then as a logarithm, we can rewrite this expression using part 1 of the equation above. So I'm just going to literally copy paste a, y, and x into the first part of the equation. So I have log base 4 of x, so x was 64, is equal to 3. Wow, that's super exciting, isn't it? Maybe not. Maybe it's not exciting, but I think eventually we're going to come upon some problems that otherwise we might not really be able to talk about without logarithms. Okay, so part B, 10 to the negative 3 is equal to 1 over 1,000. So the base is 10, so a is equal to 10. Y is equal to negative 3. And x is equal to 1 over 1,000. And then as a logarithm, let's move this up a little bit. As a logarithm, this is log base a, so log base 10, of 1 over 1,000 is equal to negative 3. Okay, So I think I'm going to let you guys do the rest of problem 1 on your own. As usual, the answers are on Blackboard. And we will move on to problem 2. So we're asked to evaluate these without using a calculator. Okay, so you'll notice these are all log base 10. Well, it doesn't necessarily say base 10, but because it doesn't say base 10, we know it's base 10. Does this make sense? Okay, so there's a few of these that I want to take a look at. Let's just start with part A. Why not? Okay, so what this is asking me is, what power do I need to raise 10 to get 1 million? So in this case, this is why I like log base 10. You can literally just count the number of zeros. So there's 6 zeros. So 10 to the 6th is equal to 1 million. So log base 10 of 1 million is 6. And we have evaluated that without a calculator. Okay. So 10 raised to the log base 7. So in the definition that we just talked about, remember if I had log base 10 of x, what this gave me was, when I raised 10 to that logarithm, log base 10 of x, okay, I get x. For part B, x is equal to 7. So if that is at all confusing, take a minute to think about that. Part C. So log of 10 to the 4th is asking us, what power do we need to raise 10 to get 10 to the 4th? I think we need to raise 10 to 4 to get 10 to the 4th. So this is equal to 4. Okay, maybe let's do part E, and I'm going to save D and F for you guys to do. Log base 10 of the cube root of 10 is asking me, what power do I need to raise 10 to get the cube root of 10? But remember that I can rewrite the cube root of 10 as 10 to the 1/3. So the power that I need to raise 10 to give me the cube root of 10 is 1/3. Okay, and before this video is over, I want to go over... Nope, just kidding. Just kidding. Guess we're just doing parts 1 and 2. Okay, great.